We have this construction and we're asked to show that this shaded grey area is equal to the area of the triangle. That is pretty neat. So let's give it a go. It's worth just spending a bit of time kind of staring at this and thinking how we're going to add things together. So for example, you can shade it in like in your head or on the paper, but if we find this blue area and add it to this blue area, then we've got the shaded area, but we've got some extra bits. So if we then also find the area of the triangle, but then subtract all of this, then we're there actually. That will equal the shaded area. So to put that into words, shaded area is going to equal, I'm going to call this one semicircle 1, and this one semicircle 2, plus area of the triangle minus semicircle 3, which is like, you see what I mean? Okay, good. We've got like a strategy now. It's just working out these areas. So I'm going to label the sides of the triangle A. That's going to be the diameter of this circle. And then this one will be B, and the longest one C. That then links into A squared plus B squared equals C squared. So S2, right, the radius is then going to be A over 2. So it's going to be a half times, I don't know why I'm starting with S2, but I have, pi r squared, so pi times a over 2 squared. So this is pi a squared over 8. Okay, and that's that whole semicircle here. And then for similar reasons, we can then quote the other areas of the semicircles. Like we don't have to show all our working. This one's going to be pi b squared over 8. And this one pi c squared over 8. And the triangle is going to be a half AB, because the half times the base times the height. Use this 90-degree angle to sort that bit out. So the shaded area is then going to be S1, which is pi b squared over 8, plus pi a squared over 8, plus a half AB. That's good, because we kind of want, this is what we want to end up with, minus half, sorry, minus pi c squared over 8. Okay, because I've got this formula here, it's all just coming out nicely. I'm hoping it's making sense. So I'm going to factorize out the pi over 8, and then it's going to be a squared plus b squared minus c squared plus a half ab. But now I can use this. It must be that a squared plus b squared minus c squared is actually equal to 0, because c squared is a squared plus b squared. So this is equal to 0. They're going to cancel out, and I'm left with a half AB, which is the area of the triangle. Okay, so I really like that result, and the proof, shaded area must equal the area of the triangle.